live viruses in many parts of our production facility. Now, we inactivated the virus for some of the vaccines, but still, I had live viruses that I had to be concerned with. What happens to viruses when I hit them with caustic? Right, they blow apart. Oh, no, that's not my next slide. They blow apart into protein bits, little bits of TOC. So that's how I justify using TOC. But I have to prove that they break apart into bits of TOC. And that's something new in the industry. I've done a pretty good job lately of doing what they call degradation studies to prove that your proteins, your viruses, break apart into TOC bits and there's nothing left that's recognizable of the actual mother material. But right now, and eventually, we're hoping that enough companies will do this so we can just point to their studies and say, see, they've already proved it. I don't have to prove it too, right? But right now, we're still in the state where you really need to prove it yourself, that the caustic breaks it apart. At my facility, we used meat, raw meat, yum, to make the tetanus vaccine. So how do you make tetanus vaccine? You take hamburger, right? You grind up the hamburger, you inoculate it, and you let it rot. Yep. That's how you make the tetanus vaccine. And then you purify it to get the vaccine on. So with meat, I've got to worry about prions. The only way to control prions, of course, is to control your source. So I will say my second week is I got a call, and they said, we need you to do cleaning validation on a new meat grinder. I'm like, oh my God, meat grinder? We have a meat grinder? Yes, we have a meat grinder. For the tetanus vaccine, you know. Right? I said, you know? Like, no, I didn't know. I said, where did you buy this meat grinder? Oh, well, you know, like, from Bella's. Like, are you kidding me? Right? And I got to clean this down to Bioburden specs of 10 CFU per 100 ml. It's got threaded fittings. Right? Everybody in the bubble knows what I'm talking about. Right? And they put silicone grease on it when they twist it back together. I'm like, oh my God, this is terrible stuff. But yeah. In fact, there's one process, yellow fever, that uses mason jars. Mason jars is part of the process. That's how old the process is. The jars actually say mason on them. And they said to me, we want you to do cleaning validation on the mason jars. Are you kidding me? Right? For as much as mason jars cost, make them single-use disposable, would you? Right? I mean, I know that's a lot of glass to put in a landfill, but we know the cost of cleaning validation, right? Huge. And then not only just the cost of cleaning validation, but the cost of cleaning them every time to give them back. So, yeah. Other things I had on my site to worry about, formalin, sucrose, right? But what do we know about sucrose? So when we do a cleaning validation, we have to hold the equipment for the extended or the long dirty hold time. What happens when you let sucrose dry on equipment? You get an equipment candy apple, right? How do you get an equipment candy apple off? You melt it off. You got to use temperature. So you need to understand the soils that you're working with. I'm not saying you have to be a chemist, right? I'm not saying you have to understand how these things react and that the hydrogen of the sodium citrate does this, phenyl reaction thing. That's not what I mean. You need to understand your soil stream and how do they interact with caustic. What happens when they dry, right? I've got aluminum and mercury. Well, those aren't great to have, and of course, that's one thing in the vaccine industry that gets people all up in arms is when you talk about the aluminum and the mercury that we use as preservatives. Triton X, though, woohoo! I got Triton X in my product. That's a detergent. Oh, that's a detergent. And I actually have detergent in my product, so that can't be good. But it is. We use Triton X. Also, in the flu process, I have allotonic fluid. I have blood. I have chicks. Right? The flu vaccine is made with eggs that are incubated to have chicks in them. The chicks are what give off the flu vaccine, as well as yellow fever. We'll talk a little bit more about that. Your soils may change with heat, pH, and time. Remember, I've got eggs. This is what happens to eggs with a change in temperature. So understand what happens to your soils with the change in temperature, pH, and time. Gelatin is another compound that I have, and my arch nemesis, anti-foam. Does anybody have this arch nemesis at your facility? Manufacturing loves it, I know, because they don't get foaming then. But what is anti-foam? Anti-foam is basically silicone, right? How do I get dried silicone off equipment? I have to melt it off. It doesn't dissolve in anything. That's kind of the point, right? Is that it doesn't dissolve in anything really. So it's very very difficult to get rid of. We also had one case where anti-foam, when it was heated and exposed to a high caustic temperature, it turned orange. So we swabbed the equipment, we saw orange, we said, oh, yeah, that's just rouge. And we'll talk about rouge in a minute. So we said, that's not a big deal, that's just rouge. But we had to send it off for micron electrograph stuff, because that was our requirement at the site. They came back and it was silicone. Oh, that sucks, right? Had to get the anti-foam off the equipment. And again, that was just purely temperature. I had to put in a lot of hot Wi-Fi for a long period of time and melt it back off. Bacteria. At my facility in Swiftwater, and at Genzyme actually, we use bacteria to do the fermentation. Some of our bacteria are gram-negative. What happens when you use a gram-negative bacteria? You get a ton of endotoxin. So in my flu process, I had 10 to the 12th CFUs per ml of bioburden in the product stream. 10 to the 12th, yep, CFUs per ml. Huge amounts of bioburden. And then in my Menactra process, I had 10 to the 6th EUs per ml of endotoxin. Huge amounts of endotoxin. So why, do I ask you, did I have to clean 10 to the 6th EUs per ml down to less than 0.25? Just so I could load the next batch, 10 to the 6th, down to less than 0.25. Right? That was ridiculous, and we finally got out of having to do that, especially since it was dedicated equipment, for God's sakes, right? So be careful about that. How many of you apply WIFI specs at your site as your cleaning acceptance criteria? A couple of you? So some of the auditors, if you get an auditor who's outside the bubble, and you say, I cleaned WIFI specs, that auditor's like, oh, that's cool, right? You've been on the WIFI specs every time, that's pretty neat. You get an auditor inside the bubble, they're like, prove to me that's sufficient. How do you know WIFI specs are sufficient? How do you know you're not over-cleaning? How do you know you're not under-cleaning, right? Because WIFI specs might not be sufficient. Can you go lower than WIFI specs? So you have to be careful about auditors that are in or out of the bubble. But WIFI specs, a lot of times, are way too stringent for what you need to clean. But QA loves WIFI specs. And there's my endotoxin. So endotoxin, one thing to know about endotoxin, it's very sticky. It likes to stick to glass and plastics. And also there's some polymers in plastics, some elasticizers in plastics that interfere with the gel clot method. And there's actually some components in different detergents that interfere with the gel clot method. So you can get a lot of false positives for endotoxin depending on what you're sampling. We eventually had to just throw out some of our plastic components because we couldn't get the sticky endotoxin off. Detergent doesn't do a great job against endotoxin. Hot WIFI is what you need for endotoxin. Really, really, really hot WIFI. And this is where I talk about the virus. It goes from being a full virus to a split virus, is how we generate it. And then it breaks apart into just a bunch of TOC bits, right, when you hit it with the caustic. You also have this phenomenon of denaturing, right? So you have your folded proteins, hit them with caustic, and now you have unfolded proteins. This is typically harder to clean than this, but not always. Not always. We'll talk a little bit about how you can learn more about your soils. Here's some more about the protein folding structure. So one thing that's interesting is soybean casein digest media. Do many of you use that? No? So soybean casein digest media undergoes a phase transformation from quaternary to tertiary at about 65 degrees. When it goes from quaternary to tertiary at 65 degrees, it becomes harder to clean than it was when it was quaternary. So again, and our WIFI, our ambient WIFI ran at about 55, 65 degrees at times. So again, something very important to know. This is very interesting. This is called the shock front. This is a phenomenon. This is basically like when you dry soils on a coupon. This is what you see, right? You see this coffee stain outline when you dry them on a coupon. And every time you think, oh, what's that? What's that? Oh, I don't know, just clean it. But this is what happens when you dry your soils on your equipment, is you get all these shock fronts. So we were having a very difficult time understanding why final formulated flu, which is mostly buffer, right? Very little product, mostly buffer. Why was final formulated flu showing up to be harder to clean in our coupon studies than bulk flu, which was not yet formulated with all that buffer? How could that be? That makes absolutely no sense, right? When you think about it, off the top of your head, outside bubble, or outside bubble again. So final formulated flu versus bulk flu. The reason was the shock front. This shock front is about 8 times more concentrated than the inside of your circle. The more ability molecules have to move, the more concentrated your shock front's going to get, right? Because more molecules can move to the side. They're not being blocked as it dries. The bulk flu, as it dried, just kind of settled down and dried. So you didn't see a definitive edge. It just dried down and was like as a solid clump. Whereas the final formulated flu was able to move, right? We have movement of the particles, and we got this shock front. When we were doing cleaning on the coupons, the inside would clean very quickly, but the shock front took forever to clean. And that's why we were failing final formulated flu in the coupon studies. You need to make a list of your soils from your process. So here's some examples, right? Because again, you can't do cleaning validation on every soil, on every piece of equipment. You'd never be done doing cleaning validation. So you're going to have to group your soils in some way. You want to obtain subjective data. So this is actually go out on the floor. Go out on the floor and rank from the operators. Cleanability, you can get viscosity out of tables, solubility, right? But you want to understand from your operators, because again, you know, I always say frontline supervisor was my most favorite job, and I learned the most in that job. The operators know. You can go out and ask them, what is the hardest product to clean? What is the hardest piece of equipment you have that you're cleaning? And they'll tell you. They don't know why, right? But they can tell you. And then it's kind of deductive reasoning, right? You got to figure out why you get that hard to clean soil. So here's an example of one we did. So there's the people across the top, Ivy, Mitchell, Paul, Gladys, and they all gave us a ranking. And it's all subjective, right? It's not something I give to the auditor and say, yes, so Gladys says that tetanus toxoid was the hardest to clean. But when you look at the scores, obviously, from a bulk perspective, right, from a ballpark perspective, my flu zone, not so hard to clean. My tet-meninge, much harder to clean. And what particular soil there? Well, so that's pretty tight. These are all pretty close. This one's not as much, but obviously this tet-meninge is harder than flu. And so I'm just looking for ballpark numbers from that. You also want to go through your product file and find out how much toxicity from all the different reagents that are in your product. So for product A, B, C, D, right, I've got formalin, thimerosal, sodium hydroxide, sodium citrate. What's their solubility, what's their toxicity, and what's their concentration in the different products. Because again, I'm trying to group my products. I'm trying to find my worst case toxic product and my worst case cleaning product. Two different things, right? My hardest to clean soil might not be toxic at all. It might be sugar, but I still have to clean sugar. But I have to clean it down to the most toxic compounds acceptance criteria. So on to the grouping of soils. At this is how they group their soils. They identify the soil for evaluation. Does the soil contain protein? If yes, you go this route. If no, it's in group 4. So that would be your buffers, right? There's no protein in buffers. So they go here. Does the soil contain DNA or RNA? If no, you go here. So that might be your medias. If yes, it's a DNA, RNA of viral origin. So you ended up with bacterial, viral, this would be viral, bacterial, media, and buffers. That's how they kind of group their soils together. That's just one example. You could do a more broader grouping and say, yeah, if I can clean my product, I don't have to worry about the buffers, right, as a different group. You could do that if you wanted to. You just have to justify. And again, risk assessment, risk assessment, risk assessment. Right? Oops, sorry about that. But I suggest you do risk assessments, and for God's sake, if you're going to do them, document them. Okay, so that's just verbiage about those soil groups. Now choose a worst case soil in each group. How many of you have done worst case soil challenges before? Anybody? Coupon studies, worst case? No? Okay. So there's many different models that have started to arise in the industry. Has one model where he takes a shaker bath, he puts the coupons in the shaker bath standing up like this, right after he's soiled them with the soils, let it dry. The shaker bath, of course, shakes all the coupons at the same speed, back and forth, so they're exposed to the cleaning solution. Then you take them out, you weigh them before you soil them, you weigh them when you soil them, and you weigh them after you clean them. And that tells you how much you removed. Some people will also take TOC samples of them, before you cleaned it and after you've cleaned it, so you know TOC-wise what you're getting. We use weight, because you don't have to have a validated analytical method to use weight, but you have to have a scale that goes down to 4, 5, 6 decimal places to be able to use weight. Also, there is a flow over model. So there's like a peristaltic pump, and it will flow over the different coupons. We'll do pace studies for you that are similar to what I'm talking about, as will who's out west. Does a flow over model, so they build like a waterfall, and they attach the coupons to the wall, if you will, and the detergent flows over the coupons. So one thing that we did at was we started using a disc tech, and I'll talk about that a little bit. Oh, sorry, before we get to that. This is the white paper exercise. So a lot of you probably have done the white paper exercise, where you look at the solubility, the toxicity, right, what the subjective data said, and you do this white paper exercise and say, yeah, from the white paper exercise, these couple fall out as my worst case soils. Because again, I might have, when I look at a process stream, 30 different soils, because each process step gives me a different soil, right? I can't do coupon studies on all 30 soils, I'd never be done. So I do my white paper exercise first to kind of kick out the worst 5 or 6 out of the bottom. But white paper exercises are not enough. I can't stop there. The agency will definitely give you some 483s over that. So you're going to find your worst case, again, based on difficulty to clean. I'm over here. Difficulty to clean, toxicity, and your tracer solubility, right? Don't forget your cleaning agents. So your cleaning agents could be your worst case soil. Make sure you group those in there as part of your white paper exercise. And then you want to do your laboratory coupon studies. If you want to use an analytical method like TOC, it would have to be validated for every soil you are testing. Yeah, maybe not, right? So this is just a, if you will, a design space study. So maybe it doesn't really have to be validated for every soil, but some companies would say it would. And if it is validated for every soil, how do you apply the soil to the coupon when different soils have varying concentrations of components? So how much do you put on a coupon? Weight turns out to be a very good option for coupon studies. So we were in the lab, and we were taking a bunch of beakers, right, trying to buy a bunch of overhead stir bars, or stirring apparatuses, right, putting together the monkey bars, right? Those of you who work in the lab know what I mean about the monkey bars. So you got all these stirrers attached to the monkey bars, and these beakers, right? We bought all this stuff, and I had someone walk in the lab and they go, "What are you doing?" And I said, "I'm doing coupon studies. That's what I'm doing." He says, "Well, why don't you just buy a dissolution bath?" I go, "What?" Do any of you know about dissolution baths? Yeah, a couple of you. Yeah, so I didn't. I had never been in tableting before, but we ended up just buying a dissolution bath. We called them gravimetric last to leave determination, gravimetric being weight, right? We're going to go down to 6 decimal places and weigh the coupons before, after we soil them, and then at the end. So the gravimetric last to leave determination, coupon preparation is very important. Of course, the coupons have to be clean. They can be of multiple materials of construction, right? You can get coupons cut from just about any material of construction you want. I just ordered some polysulfone because my bubble trap was made of polysulfone. And I had my QC department going, "Where are we going to get polysulfone? We can't afford to buy a bubble trap and cut a bubble trap. Where are we going to get polysulfone? Where are we going to get polysulfone?" You know where I found polysulfone? Amazon.com. No, really, I'm serious. I paid $200 on Amazon.com for 4 sheets of polysulfone. And the sheets were like this big, right? And they said, "Well, what are we going to do with that? We don't know what to do with that. We can't use that. That's too big." Blah, 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 blah. So I paid a machine shop $70 to cut the polysulfone into 4x4 squares. Like there, now you have polysulfone coupons, right? Jeez Louise. But you can buy coupons of just about any material of construction that you want. So for the coupon preparation, you want to select the material of construction that matches your process. You want to label the coupons, don't skip that step. And the way you label the coupons would be best to do an etching, like a laser etching, because you don't want to add weight to the coupons. Thoroughly clean the coupons prior to analysis. We used a desiccator because we found if you didn't put the coupons in a desiccator, their weight kind of drifted based on the humidity in the room. And unfortunately, my cleaning lab was in a mobile trailer, right? Which made the floor move, right? So when you're trying to use the scale, you had to put a piece of cardboard up in front of the vent so the air didn't move in the room. And you had to tell everybody, don't move, I'm using the scale. Right? Don't walk, I'm using the scale. So it's kind of crazy, but that's what we had to do. And again, you want to get the tear weight of all the coupons. Here's some different coupon material constructions. Notice the list, and again, you can get them of anything. We had Norel, Viton, glass, Velox, titanium, aluminum, polypropylene, Teflon, all different materials of construction. Now, do you have to do every material construction that exists in your facility? No, no. What we do at Swiftwater and at Genzyme is we say, I'm going to calculate all the surface area of my equipment, right? And if this particular material construction makes up less than 5% of that surface area, I'm going to call it negligible, and I'm not going to test that particular material construction. Okay? But if it makes up more than 5%, I'm going to test that material construction. So this is how we labeled the coupons. We did laser etching or chemical etching to get them labeled. The clean with a method of detergent compatible with the material construction, so you don't want to disintegrate your coupon with your cleaning method. We used a sonicator, Millicue water. We did all this in a biosafety hood. Then we dried the coupons in an oven, right, and put them in a desiccator. This was prior to soiling them with the soils. We weighed them to get their tear weight. And again, we had to put up our cardboard and everything else. But so you want to get a very low scale, right? You need to have many, many decimal places. We went down to 6 decimal places because these coupons are small. And you actually have to get smaller than 2.5 by 2.5 or 4 by 4 or 2 by 2. They're smaller coupons because of the weight. Soil preparation. We accurately measured volume, mass, or dose, whatever it was. But the point here is you're trying to compare apples to apples, right? I want to soil the coupons with Flu the same way I'm going to soil them with Minactra. If the Minactra flows through the line and it dries on the line, then Flu flows through the line and dries on the line. I'm not going to try to soil specifically with the same amount of TOC, right? That doesn't make sense. That's not how it soils in the field. So think about in the field, how things soil in the field. Because again, I want to compare apples to apples. This little step right here, you learn huge amounts about your soil, right? You learn that sucrose dries like a candy apple. You learn that some of your products pop, like popped rice, off of the coupon as they dry. Right? You learn that other soils won't even stick to the coupon. Like you have to carefully carry the coupon to the dissolution bath because the soil might fall off otherwise. You learn huge amounts doing this. I can't even tell you how much. And then here's our dissolution bath. So the dissolution bath, of course, controlled volume and concentration of detergent, the temperature, the turbulence, right, because all the paddles spin at exactly the same speed, and of course the time. We control all those things in our dissolution bath. There's a nicer picture of it. This is the model we used, the 2100C. And of course the Distech vendor was like all thrilled, right? Oh my God, another application for our machine. Let's help market that. So you might see some advertisements about using a Distech for coupon cleaning. And there's a little bit more about the Distech. So then finally you have to do the evaluation of the data. And again, you learn a lot by watching the Distech run. When you put the coupon in the detergent, we had some soils that just kind of floated off the coupon like a sheet, but the sheet never dissolved. And what do you do with that? Right? The coupon's clean, but oh boy, that's a problem waiting to happen. I'm going to plug something because I've got this sheet of stuff just floating around the room. You want to get the dry soil weight pre-cleaning, the dry soil weight post-cleaning, and then the percent soil loss. You're going to compare the percent soil losses from one product or one soil to the next, and that's going to tell you what was the hardest to clean, right? What soil didn't clean well in this detergent. You can vary your detergents, right? So you run one study in 1% CP310, run your next study in 2% CP310. But each time, I'm doing 6 replicates, is what I'm doing. Now, you could do more of a DOE type design, because these are all different beakers. I could put different concentrations in all the beakers during one study if I wanted to, right? However you want to design the study, but you've got to do some lab work to find your worst case soil. You can't just do the white paper exercise. White paper exercise was a thing of the 90s. That's over. We're now in the 2012s, right? You've got to do more than the white paper exercise. Are there any questions on that? you've done in the field that's been helpful, that's helped you learn about your soils? No? Nothing specific? Okay. So I can't tell you enough about getting in the lab and playing with your soils, right? Learn about your soils.